All right, so I'm going to get started. I'll just share my screen and get the Zoom window out of the way. All right, so hi everyone, thanks for joining. I'm going to be giving kind of a quick overview of just different things we've added to our UI and different changes we've made to our UI over the past, I'd say 6 months or so. Most of them are more recent, but I'm also going to be touching on older things because I know that people aren't necessarily following, so giving kind of a general overview. I'll dive right in. So the changes that we're going to be focusing on, and by the way, if anyone has any questions related to these changes or other changes or just questions in general, feel free to ask in the Q&A. And we'll be happy to answer, or I'll be happy to answer. So first of all, we're going to be, I'm going to show you guys the new SignOn read view in the outputs. I'm going to be showing how we completely changed the output page. So really modified it to be completely different from what it was, and just the differences and what the thought process was there. We've added a feature of breaking down the statistics in a data source by an event type field, and as well added usage statistics per output and data source in the clusters page, so you can kind of understand how your environment is behaving and what's using your what's consuming most of your resources. We have a bunch of new output connectors that I'll get into in more detail, and how they work and what caveats they have. We also added single sign-on using SAML 2.0. And finally, we added support for SelectStar statements. I know it says in Upsolver outputs, but it's actually in Upsolver outputs, S3 outputs, and Elasticsearch outputs, and more coming soon. So that's kind of just a brief overview. And again, if you guys have any questions that are tangentially related or other topics that you want to talk about, I mean, these are just a subset of the modifications we've been making. So of course, if something else is interesting, just feel free to reach out. All right, so with that, I'm gonna get started on the SignOn read view and outputs. So basically, this is something that's been bothering me specifically very often, is that when I go into an output, let's pick so many to choose from. So if I'm looking at, it used to be that I didn't have a good way to understand what was actually being produced by the output. And this metadata was actually always there. It's just something that we'd never exposed. So we used to show, well, I mean, I'll get into that. We used to not have a tree view here at all, but we used to show information on the data sources, which is very useful while you're building your output, but less useful after it's run and when it's in a running state. So now you can drill into the output itself. So this is statistics from the output that's being generated, and I can drill down to see events over time and value distributions, total values, all that. So everything you'd normally see on a data source, once you run an output, you're going to see it on the output itself. So you can see here again, value distributions of field, and that can be pretty useful for situations where you just want to see that your output is behaving as expected. It's outputting all the fields you wanted. If a field is always null, for example, or if the values that it's getting aren't what you expect. So that's really the use case there. And in general, you're going to see the tree view. So actually, this is I was confused. This is actually the same page for both. So if you're creating a new output and working on it, this is actually, so I would say a moderately new feature. And let me just create a new output so I can demonstrate it. So it used to be that you didn't have a consistent tree view on the left. You used to need to, you had a little drop down in the middle. You need to select the tree, and then it would pop up, and then select, and then it would disappear, and you didn't have a good way to see statistics. So now the tree view is going to always be here. You also have this new shortcut where you can just click a field, and it's going to show you the kind of like just the top 5 values, as well as drilling down, so giving you the full statistics. So all of that is going to be kind of following you throughout the entire process. So this pane is just always here. You can still do all your definitions using the UI mode, like adding I don't know, let's do just something, is mobile or true. So not changing anything, is also mobile. So you can still do all of your transformations normally using the UI mode or using the SQL, which I'm going to get into. I'm not sure everyone's aware of the SQL, but so you still have all the same stuff, but the tree pane is just going to be here throughout. So you can just work with that as you go along. So that's the SignOn read view in the output page. In general, we've completely revamped our output page. I think most of you have seen the old version. It looks almost nothing like what it looks like now. I think the main difference is having a more consistent user experience, both between different output types and then also between the SQL and the UI mode. So it used to be that that if you were to switch to UI mode, it would change the entire UI, and then you'd lose all of your buttons and quick add stuff and things like that. So here now I can continue modifying my my output using the UI when I'm in the SQL mode, and it's just going to let's say do something like this so you can see what happens. So you can see that it's just modifying the UI as we go along. So really, the UI and SQL mode, rather the SQL. So the UI and SQL mode are essentially just representing what you've already created, but as far as the experience of what you do on top of it is going to be consistent regardless of if you're developing via the UI or in SQL. Aside from that, we've cleaned up a bit of the UI itself, and specifically also unified the preview to a single pane. So we used to have a bunch of different previews. There's like a preview on top, and then a preview in only lookup tables, and then another preview that you could do on the same page from a different button. So now you have a single preview. It's always going to open up in the same spot. We've also added a bit of functionality. I have a Zoom window here blocking it, but we've added additional functionality that you can deactivate filters if you want to see kind of a broader result. Not sure that I ever have a null channel. Yeah, no, it's empty. It's always full. But in theory, so yeah, actually I could, or this is already disabled. But where is it? Yeah, still need to figure out the coloring and stuff like that. But anyways, you can see the previews as well as you can select the time range. So I could say, for example, like I wanted to run something from the 10th of March, and it's going to select samples for the preview from then. So that can be helpful in order to just be able to kind of navigate a bit better and select some fields. We're continuing to revamp this, so this is still a work in progress. But definitely a far cry from what we had in the past. As well, if I just quickly duplicate this and create, for example, an output to Elasticsearch. So in tabular outputs, it's still remaining a table and everything's staying the same. If I switch to a hierarchical output, like Elasticsearch, for example, and assuming there we go. So here, the preview is actually going to show me individual JSON documents. So this is going to be the same for S3 outputs, assuming you selected hierarchical and not tabular. It's going to be the same for lookup tables, and trying to think if we have any other for Kinesis and Kafka outputs. So all of those are going to have a preview that looks like this, where you can actually open a document and view it as a JSON or as a table, as well as download the document directly. And we're soon going to add functionality to also be able to upload a document back. So you could upload this and then have the preview run on specific documents that you've selected. But that's coming soon. I'm getting ahead of myself. So yeah, hopefully the new UI here is going to give you guys a better general experience of the system, as well as allow us to iterate much faster, because we don't have to maintain a lot of different views that look at the same thing with different components. So that's the new UI, the new output page. we've also added the ability. So this is a feature that that's been requested of us several times. And essentially what we're talking about here is that often data sources arrive that have multiple different types of events within the same data source. So a good example of that is going to be a CDC use case where the entire database is going in and you have a column called table name, which just has the name of the table. And then each table obviously has its own columns, and then they're all just mishmashed together. And that used to be kind of a mess. I mean, you could see what columns there were, but you couldn't know which were associated with which table. Same thing goes for just normal event streams where you have a bunch of different event types that are going to have different fields. And that can even be more annoying when you have nested structures that sometimes a nested structure, sometimes a field would be a nested structure in one event, and then it might be a flat structure in another, and then things get very, very tricky and messy. So what we did is added the ability to split the statistics in the data source based on an event type field. So if I go into this, and I'm not sure I've actually split, yes, it's split by channel grouping. So you can see here, and actually I'll go into a different data source to show you guys how to define it, assuming I haven't done it here. Yeah, so any field that has a low number of distinct values, so basically up to 1,000 distinct values, is a candidate, so is allowed to be used as an event type. And you have the button right here. We're actually going to move it to the properties soon, but it's going to do the same thing. And basically, you're just going to click use as event type. It's warning you that it's actually going to do something because this is scanning the data. It's a very fast process, but it still needs to go over the data to create the new statistics. And if I were to click OK, or I'll click OK and show you guys what happens. So you get the event type field up here, which basically lets you select a value. Of course, the statistics take a moment to get created, so I won't, in fact, I'll clear it, so it won't actually run anything. And show you on this GA sessions, but it takes a few minutes for it to get started. And then essentially what you can do now is select a value from the dropdown. And then when you do that, it's going to filter both the, well, yeah, didn't actually run here. It's going to filter both the tree on the left, as well as the graph, showing only the events that are relevant to that event type. And this information also shows up in the output page. So currently it's in read-only mode. So if I were to go back into my output, you can see here that I can set the event type filter value. And again, just choose which filter I want. It's just gonna, at this point, it's just going to filter the list. So you can see that the number of fields changed. But other than that, it's not going to affect the output itself. So it's not adding a filter directly into the output. You'd still need to do where channel grouping equals paid search if you'd wanted to represent this data, but it still lets you select fields that are relevant to what you're looking at. Cool. So so that was this feature. The next feature is basically so the problem we're trying to solve here is that people often have a lot of different outputs. And so they have a cluster, they might have 5 or 10 servers running at any point in time, and it's scaling, and it's very hard to understand what the impact is of a new task as you run it. So basically I would run a new task, my cluster would scale up, let's say to 16 servers. After a while, it would scale back down to some number. And then because of daily variations in the number of servers, as well as under overutilization, it's very hard to kind of understand how much actual additional capacity I need for that new output. So what we've done is, if you go into the clusters page and you look at your compute cluster, so you can see here breakdown over time, and this is dynamic. I can, let's say, change that to 7 days, a breakdown over time of the server that's running and all the different tasks. And this is a demo environment, so you can see that we're always running and stopping tasks. So it looks very colorful. But essentially what you're seeing here is, given a point in time, and then also over the entire range of time, you can see each task, how much of the cluster or how much of the compute units that you actually had was it consuming. So keep in mind, first of all, that this breakdown is based on the actual compute units. So if I have, you can see here that it's always one because our demo environment is limited to one server. But you can see here, on the other hand, that the utilization isn't always 100%. So even if at this point, for example, the utilization is 10%, this is still going to sum up to one, to a full unit. But it is saying, given the units that I have, how much of the work is being done in order to complete each of the different tasks. So you can see, for example, that at this point in time, yesterday, I had demo Upsolver, which was using almost the entire cluster. Also, in addition to the breakdown by task, so that can be very useful for, like, I run a new task, I want to see how it's working, or if it's overutilizing resources versus what I expected. But another thing is that often customers use workspaces in order to separate work into different business units. And then it's often very useful for a manager to see actually how much is being consumed of each business unit, assuming they don't each have their own cluster. So we have a lot of people doing it this way or that way. But then you can simply switch it to group by workspace. And then you can see that different tasks associated with different workspaces, what their distribution is. And then if a task is associated with multiple workspaces, it just shows up as a separate group. So that's, again, like, you can use that in order to get a higher level view of kind of which projects or which business units are using the most resources out of your compute unit. And I would generally recommend people to take a look here. Often you'll be surprised that you suddenly discover some output of yours is consuming a lot more than you thought because it's doing a count distinct, which uses up a lot of resources relative to other things or something like that. All right. Next is the new output connectors. So we've been working on adding, of course, we're adding a lot of functionality to the existing output connectors, but as well, we're starting to branch out and give you more and more outputs. We are, by the way, planning as well additional database output. So soon you're going to have Postgres and MS SQL, etc. But what we're talking about today is what we already have. So we've recently added Kinesis and Kafka as streaming outputs, as well as Snowflake as a data warehouse output. So Snowflake behaves exactly as a Redshift output would. So it's a database connector. Currently, it requires a table to already exist. And then you'd map it to the table, and then you have the same look and feel as Kinesis, as Redshift would have. But of course, writing the data to Snowflake. And that has our same exactly once guarantee. So in general, all of the outputs that we have here, aside from Kinesis and Kafka, have an exactly once end-to-end guarantee. So for every event in the source, you're going to have one single event in the target, unless you filtered it out or you're doing an aggregation, something like that. Kinesis and Kafka are different. Kinesis has an at least once guarantee. That's not something that we have any control over, because Kinesis doesn't have any kind of semantic that would allow an exactly once guarantee. Kafka today is also at least once, but is planned to be exactly once. So Kafka from version, I believe 1.1, has an exactly once semantic, which can be defined in the producer layer. So we're going to add that functionality. But currently, both Kinesis and Kafka have an at least once guarantee. From your perspective, it's not going to create a lot of data duplication. I'd probably expect about maybe 1 in 1,000 or 1 in 10,000 events to be duplicated, something like that, possibly even less. But the possibility is there. So you wouldn't necessarily expect every single event to arrive only once to these, but at least once for sure. Aside from that, they all have the same UI as our normal output. So again, like with the new output page, we've really put a lot of work into consolidating everything. So you're going to have just a consistent UI regardless what type of output you're using. All right, and then coming soon, so we're adding into the Snowflake as well as to Redshift and MySQL. create, update, and delete support. So create table support, meaning that you'd be able to map it just like an Athena table. You don't need to have a table existing in your database. We would create the table with the column definitions that you have. As well, if you go into Upsolver and add a new column, remove a column, it'll update the table based on those changes. So you don't need to go into the database and actually manage the table. And as well, upsert support. So today, upserts are supported in MySQL. In the future, in the near future, we're adding upserts as well to Redshift and Snowflake. In both Redshift and Snowflake, upserts are going to impact performance. The data warehouses aren't, let's say, aren't built for that kind of use case. But that's definitely going to be a use case that we support, and we're going to add that as a first-class citizen to match all of the other outputs that do support upserting today. Next, this is something that again came up a lot with different users. So we added support to single sign-on using SAML. It also has provisioning capabilities. So basically, you would integrate us with your either Okta, Azure Active Directory, or OneLogin identity provider. We have in our documentation, probably should have opened this ahead of time, but we have explanations on how to connect and how to go through that flow in our documentation, including going into their website. So you don't like, it really explains it from beginning to end for those 3 identity providers. And what we're going to do is pull in both the users that you configure for Upsolver, as well as those users groups. And those groups are going to be separate from the groups that you've created in Upsolver. So that's a pretty useful way in order to manage permissions on an SSO level. So you're going to give permissions to the groups that the users already have. And then we're going to request from your Okta, for example, anytime a user logs in. So you don't need to actually remove a user from Upsolver. If a user, for example, leaves your organization and you delete their user from Okta, they won't be able to log into Upsolver either. Okay, finally, so we've added support for SelectStar statements. This is also something that came up a lot. Currently, they're only supported for schemaless outputs. So from this list, you're going to see Upsolver outputs, S3, and Elasticsearch outputs. So all of these outputs don't need to define, as well as Kinesis and Kafka, it also works there. So these outputs all don't need to define a schema for the target. So for example, in Athena, we create a table and need to maintain that table's metadata. So within, so there we are planning to add support for SelectStar, but for now, that's still a future feature. And as well, it's only supported in hierarchical outputs. So outputs that are basically going to allow us to map fields as is into the target. If I take a look at what that looks like, so the way to define that is via the SQL. You'd simply add a select star. The star, by the way, doesn't need to be a full star, so you can do data dot, let's say data.device.star. This is actually a glob, so I can add the star even in the middle. I could, for example, put a star here, and then it would be anything starting with data and ending with device. Yeah, no, apparently that doesn't work. So forget what I said. It has to be at the end. But generally will work for any prefix as well. And this is in addition to any other fields that you've added. So you can continue adding fields normally. If there is a conflict, so if, for example, here I'm asking for data.data star, and I'm also asking for full visitor ID. So it's going to pull in anything that I didn't map to that field. So here, since it removed the data automatically, I would actually get full visitor ID twice in the output. If I were to do it like this, so I wouldn't get it twice. And I could then change also this, let's say add some suffix to that. And yeah, not sure what happened here. Let's just comment that out. But regardless, if you have an output that's writing to a field that's going to conflict with a select star, the explicitly defined output takes precedence. Otherwise, you're going to get just the fields from the star statement. This is mostly useful for situations where you're either creating an Upsolver output, so you have an intermediate step where you want to do some kind of data corrections, but you also want just all the additional data to flow through. You don't want to just lose data because you didn't happen to get it in the beginning and you didn't select for it. So that's one use case. And then, of course, the downstream things can select the fields from the data source tree just the same way as you would normally do. And then the other use case that we see is outputs, for example, to S3, so downstream systems, where Upsolver is kind of a pass-through. So again, doing some kind of data transformation, but generally you want to have an event which is going to remain intact, possibly make a few modifications, and then send it out to the other side. So you see a few people using it that way. And as I was saying, one major feature request here that we've heard a lot is that people want to send this data to Athena as well. So that's something that we're working on. We're hopefully going to support that quite soon. In that situation, there are going to be some compromises. So you can see, for example, here I have a highly nested structure with arrays and stuff like that. Flattening this is challenging in general if you're just randomly adding fields. So we're probably either going to have support for hierarchical Athena outputs associated with this, or else we're going to only support non-nested fields in the star statement. We haven't exactly decided which way to go yet. But that's kind of a preview, and we're well aware that that's a very common use case for star queries. So that's definitely something that we're planning on adding. So that's it as far as the new features I have listed here. Thank you guys very much for joining the webinar and listening. And now I guess it's time for questions. So if you guys have any questions, feel free to drop them in the Q&A. And I think there's something else here. There's also chat questions.
Yeah, Yoni, I think we have a couple chat questions, and then we can get to the Q&A.
Okay. So from the chat, I have, is it possible to get this data via the API? So everything I showed you, you can get via the API. I'm assuming that you're talking about the either the output statistics or the breakdown by data source. In both cases, the answer is yes. We are also planning a relatively medium-term feature, which is going to be alerting. So not only would you be able to query our API in order to get this information to trigger alerts or stuff like that, we're actually going to add push mechanisms to be able to send you alerts either through third-party systems like Datadog or Splunk or SignalFX or things like that, or else sending the alerts directly to email addresses or just notifications within the UI. So yes, the answer is yes to all those questions. Any docs yet? So no, generally I'm aware that our API is very under-documented. We're working on the documentation in general of the API. That's going to be both the API for getting data, so inspecting kind of what's happening in the system, as well as the API for doing data modifications. That's a work in progress. And yeah, I'm aware that it's that we're not in a good spot now, but we're hopefully going to get a lot better at that very soon. Can event type be a calculated field? So currently we don't support adding a calculated field as an event type. The caveat of that is that you can use, and that would be another usage of the SelectStar functionality. You can create an Upsolver output, which would have a SelectStar and also the calculated field that you want to use. And then you'd be able to use an event type on top of that calculated field in the Upsolver outputs data source. We are playing around with the idea of adding event types as calculated fields, but currently aren't working on that. We feel like it's a bit too complicated from the kind of user interface perspective. So for now, it's not something that we're planning on adding in the near future. So upserts for the next question is, when is upserts coming to Redshift? Soon is the answer. We're working on that at the moment. Our internal estimates, so yeah, internal estimates, that's usually, well, anyways, so our internal estimates are within 3 to 4 weeks where it should be available. Keep in mind that the way upserts are going to work in Redshift is essentially all the data is going to be copied into a temporary table. So a table next to the production table you actually want to send it to. Once a copy command finishes, there's going to be a delete command that's run against the main table from the keys in the temporary table. And then finally, there's going to be an insert into that copies all the data from the temp table to the main one, and then commits all of that in one transaction. So that's kind of the underlying implementation. It sounds heavy because it is. Redshift really isn't designed for that kind of workloads. We have staggered execution and batching of updates, so it'll perform well and it'll work at any scale. But keep in mind that it might create data delays of, depending on the size of the table. If it's a small table, it's not going to be much. If it's a large table, you might be looking at minutes or even like over 10 minutes of delay, depending on how big your updates are. And also, you're going to need to vacuum your table a lot more consistently because data is being upserted. So with all those caveats, planned for 3 to 4 weeks from now. All right. So the next question, I'll go from newest to oldest. Are the temp tables for upsert accessible for users? Yes. So I mean, it's just a table in the in Redshift. You're going to see that table. If you modify it, it'll probably break our ETL process. Generally, it's going to be a table that we're going to create and manage, but it will be visible. So it just exists within within the Redshift cluster. And same thing for Snowflake. Snowflake is a bit easier. They have a merge command, but it's still going to work with a temporary table in the middle. Okay, another question, is it possible to see in the UI if any errors are happening in the output processing? So that's actually something that I didn't add to this presentation, just because it's very, very new, so it's still a work in progress. But we do, in fact, show, and I can probably don't have anything with errors here. Let's look at something that has data over a long period of time. So this is kind of the progress that you're familiar with. We know it's buggy and doesn't necessarily show all the information. It has problems with sharded outputs, etc. So we're also working on this to make this progress indicator more robust. But as well, we've added 2 new pages that are, again, currently it's a work in progress. So we're going to revamp these completely. This is just kind of to get something out there and see kind of how it works. But essentially, and it's like I can't really see, but because of the Zoom windows, but it's showing you the process bytes that's going to become handled events and also broken down by internal processes, as well as the delay over time. And you can also change the time range so you can see how it behaved over the last 7 days, for example. And it's something that we recently ran, so it's just going down and then stayed at 0, basically. And then as well, you can see the errors. So basically in the errors pane, you're going to see, again, errors over time. So you can see just the number of events, the number of errors that you had at any given point in time. And you can also choose, so generally most errors we can resolve automatically. You can see here, for example, these are just internal errors. They're not very interesting to you. That's why they're hidden. But essentially we're showing by default errors that are associated with tasks that have never completed. So once a task completes, all the errors are hidden, but you can, of course, then show them so it matches the graph and understand kind of what errors have happened. But errors happen all the time. The most common ones are going to be access to S3, where a file just doesn't show up, just because S3 is that type of system. So you're going to see sometimes errors that pop up, and then the task completes a second later, and nothing happens. So that's why we hide those errors. But you can see everything here. And again, this is just the beginning. We're planning on expanding this quite a lot in the very near future. Okay. Next question was, why should I use the SelectStar statement when developing my transformations? What are the advantages? So I think generally I would say that for most use cases, you're not going to want to use a SelectStar. For the general situations, you know what fields are interesting to you, and you can always edit and add new fields as they come in. So you wouldn't necessarily need a SelectStar in most cases. I think the cases where you want to use SelectStar are three specific situations. The first is where you're connecting to an external system, or like where Upsolver is a pass-through, let's say, be it an Upsolver output or be it an output to a third-party system. So in both cases, you just don't want to mess with all the rest of the fields, and that's a good place to use SelectStar. That would be, I guess, 2 out of the 3. And then the third situation is very similar to the event type that you see in the data source. So if you have a data source that has a bunch of different event types, and each one has its own fields, and each one might evolve independently, let's say. So the event type filter is very nice in order to be able to understand kind of each event type, how it's working. But often you're going to want to actually work on a single event type. And then there's no point in scanning all of your raw data every time. So for those situations, the SelectStar can be very useful, where I want to select a subset of the data and all the fields associated with it. So I do SelectStar where something. And then that SelectStar is going to make sure that I don't lose any new fields that happen to show up. So I think that would be kind of the main use cases that I would see for a SelectStar. And then the last question I have is about how can I understand the consumption for each task which runs in the system. So if I look, and by the way, this is also, so here we're pretty happy with this output, but moving forwards, we're also going to have graphs per output in the output pane itself. So in addition to the 3 tabs you have now, progress, summary, and errors, you're also going to have, in the summary rather, you're going to have a graph of the utilization of that task versus the rest of the cluster. And then I think the most important thing to keep in mind is that this graph shows you the, and maybe we're going to add that you'd be able to toggle that it would show you the consumed versus actual. But this is showing you the consumed unit. So if I have an Upsolver unit that's running at 2%, it's still going to show me the breakdown of that 2%, even though the sum is very low. So that's something really to keep in mind, that you always want to look at the utilization of the cluster itself to make sure that you're actually looking at a cluster that's running at full capacity. Also, I find that that these graphs can often be very noisy, especially while developing. So if I look over the last 7 days, and again, this is a demo environment, so it's of course we're running and stopping things all the time. But I'm just gonna close these. You guys can't see that I'm doing anything. But Talia, just let me know if there are more questions, because I closed all the questions. So this looks very noisy and it's very hard to reason with. The numbers on the left are the average over the entire period. So these are actually going to be more accurate, but again, showing like demo upsert consumed 20% of my resources doesn't do justice to this graph, because it really looks like demo upsert would have used a lot more. It's using like 60% or 70%, except that we stopped it. So it was only running for a certain amount of time. So I would say, like, generally what I've experienced is that you want to be looking at this over relatively stable time periods. So when all of your outputs are running and you're not running any replays. Here, by the way, in this cluster, I don't have a replay cluster, but if I did, then I would have a toggle to switch to the replay. So in that situation, it actually will flatten out your normal cluster, because your replay cluster is the one that's going to spin up and show you all of these giant bytes that it's taking out of it. Whereas the normal cluster is just pretty much going to be flat with the new stuff adding. And yeah, I probably should have shown you guys this on top of some cluster with a replay, because it looks a lot nicer. But yeah, that being said, definitely most convenient is to look at it over time periods that are relatively consistent. And then here you can really see kind of the ratio between different tasks as far as the consumption. And again, this is mostly useful, I think, either to see, well, this happens to a lot of people that they're like, well, I don't actually even use this output anymore, so I may as well shut it off if it's using half of my utilization. And then another thing is that it brings out some points around so specific things that are a lot more expensive than they seem. So for example, again, count distinct being one of them, or upserting can also utilize a lot more performance than without upserts. Trying to think what other things use a lot of performance. If you're using a user agent parser, that's also something that tends to consume a lot of CPU. So, but anyways, like beyond me listing kind of a different functionality that tends to consume resources, you'll be able to see that directly here. So it's not necessarily going to be one-to-one with what you expect, just because there's a lot of kind of underlying stuff that's going on. Cool. So I think that's all the questions we have.
Yeah, I think that was pretty much it. So thank you everybody so much for joining us. Yoni, that was really informative. If anybody has any other questions that we didn't get to answer, feel free to send us an email and we'll get back to you. So thank you, everybody.
Thanks a lot, everyone, for joining.
Great, thank you.